In the last video, we worked our way up to the point where we had a polynomial equation, specifically a cubic equation, set equal to 0. And we're now at the point where we're going to try to apply the factor theorem to find a value of x. So luckily, the lead coefficient of the cubic term is a 1, which simply means that we need to test factors of 187 with our factor theorem. So we could go ahead and list as many factors as possible of 187, but I think you'll find that that is a specific number, a number that doesn't have many factors. So it would stand to reason that we should test 1 as a value of x that produces 0. So let's give that a try. Okay, so with a value of 1 substituted into the function equation, we will evaluate each of these terms. So if we add up the positive values, what we're going to have is 217, followed by, if we were to sum the negative values that we have, it looks to be that we do arrive at 217, as 30 plus 187 is 217, and that gives us 0. So since f at 1 produces a 0, we know that the graph of the function crosses the x-axis at x equals 1, and we also know that x minus 1 is a factor. So with that in mind, what we'll do is we'll go ahead and we will apply the long division process. So I'm just going to copy this once more, and I will bring that forward. Wait, not ready for step 5. We still have to finish this. And we'll go ahead and apply the long division to our expression here. So the factor that we had determined was x minus 1. So let's go ahead and figure out the quotient. So the lead term must be x squared. If we distribute x over x squared, we have x cubed. And from that, we're going to be subtracting 1x squared. So let's go ahead and subtract. So the cubic terms drop out. We're going to subtract a negative, which makes that a positive, and we can add minus 30 and 1, which is going to give us minus 29 x squared. So let's go ahead and bring down the positive 216, and then we'll look to further divide down what remains of the dividend. So we would need to distribute x over minus 29x, and that's going to produce for us minus 29 x squared, and minus 1 times minus 29, or plus 29x. So we'll go ahead and we'll subtract those values. We're going to get rid of the squared term that's there, and then we'll have to deal with the x terms. So let's see if we can't break this down. So we'll subtract 29 from 216. We can break that into parts. We could begin by breaking 29 into two 20s and a 9. So we could subtract 10 from 216. We'll arrive at 206. We'll knock off another 10, which is going to bring us to 196. Finally, we have another 9 units to take away. Might be just as easy to take 10 off and say 186, but we only needed to subtract 9, so I better add 1 back on, so 187. So it looks like we have 187x remaining. Okay, so a little mental math there, or a strategy for subtracting by regrouping. So now let's go ahead and we're going to drop down the minus 187, and I am so glad that we ended up with that, because that means that we're going to end up with our zero remainder. So we need plus 187. So we have 187x minus 187, and upon subtracting, we're going to end up with 0 as our remainder. Okay. So what we should attempt to do now is to further factor to see if there are any other values of x that would zero out that expression and make the equation equal to 0. So let's take this expression we have here. Let's group and copy it. And we'll bring that forward to our next slide. So what we'll do is we're going to further determine the dimensions. Now it's not so much the length and the width that we need. Remember, the problem only asks for x. In other questions you might be asked to give the length and the width. But we will have to definitely check the values of x we get to see if they fit the domain and hence be suitable for length and width. So we're going to bring forward the remaining portion of our quotient, and we need to determine if this is factorable. So when you have a quadratic expression, you could apply the factor theorem to see if there are any values that would possibly make the expression equal to 0. Or you could use an old tool that would help us to decide. So if we were to use the discriminant, we can determine the number and nature of the roots. So you might have recalled studying this in grade 11 using the quadratic formula, where the formula would determine the actual zeros of the function, of a quadratic function. The discriminant itself, which was a very small part of the quadratic formula, will give us how many real or non-real roots there are to that function. So the real roots would end up being zeros. You would see them on a graph. The non-real roots you would not be able to notice on a standard XY graph. So the discriminant, I'm just going to call it D. Recall that it is b squared minus 4ac. So the b value, I'm just going to highlight this here. It's in our standard form. Okay, so the b value is minus 29. The A value, of course, is the leading number, which is a 1 in this case. And then your C is the 187. So let's go ahead and fill in what we have for our discriminant. So we'll take minus 29, we'll square that, and from that we'll subtract minus 4 times A, which is 1, times 187. If we move further along and we square 29, which is approximately 900, right? 30 by 30 would be it. So let's square 29, see what we come up with. 841 is our product there, minus 4 187s. Okay, 4 187s. So again, let's multiply that out. In fact, well, let me share with you another strategy. Let's go off to the side of the page here, 4 187s. Okay. What I would like you to do is to think of the problem as a sum of 180 and then 7. And by that, we'll multiply each value by 4. So we'll have 400 plus 320, right? Because that's 480s, plus another 28. If you're to add all of these together, what you're going to come up with is 720 plus 28. So lo and behold, it actually works out to be 748, which was the number that we had as the capacity of the volume, or the volume of the box. Upon inspection, 841 is bigger than 748, so we can see that this difference will be positive. And when the difference is positive, okay, actually the magnitude of that difference, right, if we are to subtract 748 from 841, we're looking at, looks like a difference of 93. So just to double check my subtraction so as not to introduce any false info, my subtraction is great. So since d is bigger than 0, there are 2 real roots. Now what that means is we need to delve in a little deeper to the problem in order to find them out. So let's go ahead and do that. So remember that 93, that's a key number. So let's go ahead and work with the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, b was negative 29, so the negative of that would be plus 29. So plus or minus. Do recall that we've already predetermined b squared minus 4ac. It's 93. And 2a would be 2 by 1, which is 2. So what that means is we have 2 cases, is that x could be equal to 29 plus root 93 over 2, or the other root would be 29 minus the root of 93 over 2. So what we'll do is we'll get an estimate of these using a decimal equivalent, okay, to gain a sense of what that number looks like. So 93, let's root that value. So let's inverse. Oops, sorry, that's not what I needed there. Let's back that up. So 93, here we go. About 9.6, we'll leave it like that for now, 9.6. So we'll have 29 plus 9.6 over 2, or 29 minus 9.6 over 2. So let's determine what those values will look like. So we have 29 plus 9.6 divided by 2. It's 19.3. Okay, which is greater than 18. Okay, remember that restriction, which implies that x equals 19.3 is inadmissible. So it's not a root that we should accept for the conditions of the question, right? If you consider the context, the number does not work. So let's have a look at the other root, which should be less than 18, but greater than 0. So we'll take 29, subtract 9.6, cut that in half, and we're looking at 9.7. So 9.7 does lie within the restrictions that we have set for this problem. So we'll go back now and we'll report these x values as our answers. And that is what step 6 happens to be. Okay, so I'm going to bring this forward to the next page. Okay, because that is exactly what we've done down here. Okay, so this is what's going on here. We are rejecting solutions that are outside the domain. So in our final slide, as we bring some closure to this problem, is to make a final statement. So therefore, x belongs to a particular set of values that satisfy the equation. And in fact, I'm going to go a little more formal than this. I'm going to backtrack. I'd like to bring out that equation we had earlier. See if I can copy this expression, bring that forward. So therefore, 0 equals x cubed, etc. for all values. So for all x that belong to, so we determined 1, and then we had 29 plus or minus root 93 over 2. Okay. But given 0 less than x less than 18, x then gets modified to be another set, a slightly shortened set, so 1 comma 29 minus root 93 over 2.
Mr. Stewart, would you contact the office, please? Mr. Stewart?
If you like, there is an equivalence in the context of the problem. If we're talking about some real measurements or about a box, we could even go with a decimal notation. So it's about equivalent to 1, and then we said this was about 9.4. Okay, so in our next class, we'll look at an alternative method to doing such a problem. But ultimately, you need to have a toolbox that has multiple strategies. So what we have here, plus tomorrow, would provide a full complement of those strategies.